You've taken part of my introduction, Jerry.
I'm sorry about that.
Which was that you can't have missed that. That over the road next to Plant Science, there's a large building site. And what's going to go on to that building site? Well, it's going to be a bioenergy building. That's an artist's impression of hopefully what it'll look like about this time next year. It's not just bioenergy that's going in there. It's also going to house the brewing science, and in a little while you'll see why and what the link is between the two. And also some of the other food processing facilities that we have on site. Bioenergy. Okay, hopefully you're all familiar with these debates going on in the world today. We're running out of fossil fuels. Well, actually we've got plenty of coal, but oil's getting a bit scarce, and it's starting to hit my pocket as well as yours as the petrol pumps prices start to soar. Using fossil fuels is impacting on the environment. It's giving off carbon, causing global warming. So the need for bioenergy is twofold. It's to address that lack of fossil fuels and to try to prevent or ameliorate global warming. And liquid transportation fuels, things like diesel, lead-free petrol, the things we put into our cars, goes into aviation, for aircraft, and diesel fuel for boats. This accounts for about 50% of the energy demand worldwide. So if we can replace that oil with a sustainable source from biology, that would be good. Now, it's happening already. You're all hopefully well aware that ethanol is already being used as a biofuel. Brazil has been doing this for years. America has. And I don't know, has anybody here been on the continent and seen the biogas dispensers? Heard of E85 petrol, where 85% is ethanol and the other 15% is gasoline? No? They're cropping up all over the continent, these bioenergy, biofuel pumps. But currently we get most of that from corn or wheat starch or from sugar, coming from sugar cane or sugar beet. And that's a problem because that's competing with food. And we don't want to do that. So the UK has invested quite considerably in trying to solve this problem or help the world solve this problem. We're part of a much bigger programme across the world. And they've provided £27 million for something which is called the BBSRC Sustainable Bioenergy Centre, or BizSpec, as we abbreviate it to. 20 million of that's from government and 7 million from industrial partners. And that's funding 6 programmes, 2 of which are at Nottingham. One is based here, but is actually inter-campus. There's a collaboration with colleagues in biology, for example. And the second one at Nottingham is up at the medical school. The focus on the centre is to convert biomass into biofuel. That's bioethanol or butanol. And in the programme at Nottingham, this is our biomass, straw. Okay? So we're looking at dual crops. We grow wheat, barley, we harvest the grain for food use, and we take the residue, the straw, and we use that to produce petrol, liquid fuel. So how are we going to do it? Let's perhaps start off with something a bit closer to home and more simple to understand. That's how do we get ethanol? I'll keep this one in my pocket. So ethanol, we're all familiar with the brewing process. This is the link between bioenergy and the brewing. How do we get ethanol from sugar? This is how Brazil is doing it at the moment on a very, very large scale. Well, sugar, clearly easily soluble. Put it in your cup of tea, it dissolves quite nicely. It's actually sucrose. That's the chemical structure there. It's a glucose and a fructose sugar stuck together. And that gets broken down by enzymes into glucose, which is the main substrate for the fermentation by yeasts, brewer's yeast, to produce ethanol. Then you can drink it, or you can put it in your car and drive to the pub with it. Okay. That's relatively easy. We want to use this. And there are a couple of problems with this. First of all, it's not soluble. You're not going to be able to put that in your tea and it's not going to dissolve.